Yes, hello, hello everybody. I hope everybody, I hope everybody is doing good. Let's start this problem session. Basic muscle learning problem sessions, and it is about all these PPTs that I'm sharing with you. Believe me, this is really important for your interview purpose because if you are going through this properly, believe me, like you will be able to break the interview easily, and you will be able to understand the point as well, right? So, what is the point we have? Like fill in a problem solution. ये ठीक मत बना तबीयत ठीक मत बना So like we have supervised and unsupervised learning. Supervised learning is classification and regression. Unsupervised learning is clustering because we need to group it because we have not labeled data. Dimensional reduction is unsupervised learning. Regression or classification or categorization. Computer vision is one example you can say. K means usually reassign point to the nearest cluster center. As we go down this card clustering strategy, have not used. They are not nearby in the feature space. Assign point to the nearest cluster center. K means will multi-clustering start with each point as one cluster. They will merge the closest structure. Means if clustering estimate mode of the gradient. Especially spectral cluster. Split the node in the graph based on the assigned the similar weights. So like machine learning. Apple apply prediction function to a apply prediction function. Apply a prediction to a feature representation of the image to get the desired output, right? Apple equal to apple, tomato equal to tomato, cow equal to cow. And function to feature representation of the image to get the desired output. Okay. So we okay. So output is y, prediction function is f, image feature is x. With the prediction function by minimizing the prediction error by the training set, right? Apply f to a neighbor before seeing test example x and output predicted y equal to x, right? So this is correct, right? This is the training images, right? And image featuring we are doing, and we are training labels, training, right? And learn model, and then testing, test images we have. The image features we have, learn model, and then prediction we are doing. Okay, so this is the apple, right? We'll try to understand feature, raw pixel, histograms, GIST descriptions, KNN, like that is called the 10 nearest neighbor. Training example from class 1, training example class 2, test examples as well. So fx equal to level of the training example nearest to x. All we need is a distance function for all input. No training required, right? Training is not required because all we need is a distance function for input, right? Which is the nearest one, okay? Classifier like a linear, okay? Find a linear function to separate the classes. Okay, problem, no problem. Function, find weight function plus setup. Okay, no problem. Many classifier are available like neural Bayesian network, logistic regression, K nearest neighbor, RBMS, logistic regression, Bayesian network, neighbor Bayesian. This is the best one. Recognition, the computer image in the range, it must be noted with the correct answer that the model is contains a motorbike. Okay, right. Spectrum of supervision. Okay. Weakly supervised, fully supervised, right? And this is unsupervised, right? Okay. How well does a learn model generalize from the data it was trained in Pune? new set, new test data set, right? Component of general bias. Okay, so sorry for inconvenience. I just went for a bit. So basically, this is a generalization like bias means how much the average model overall training set differ from the true model. Error due to incorrect accurate assumption simulation made by the model. Variance how much model estimate from the different training set. Underfitting model too simple to represent like you can say high bias and low variances. Right? And here's a high variances and low bias. Right? High training error, high test error. Low training error and high test error. Okay, so this is the called the complex one. So I hope everybody is getting clear, right? And if you have doubt, please let me know because you are like a very good guys, and I feel proud that I'm at this platform. I am just sharing this knowledge. I'm trying uh, to do the transition of number of students. Like if I am able to transition of any single student from the different domain to data science domain, I will feel really myself blessed. And this is the one motto that I'm here. I'm like enjoying this session, and I believe that everybody guys will enjoy this session. Will do the same, will do their effort, right? And you guys can make it very clearly assumption, right? So my the question is that in between sometimes it's a problem. Is that like you guys are not interacting? That's what you must interact with me. You must came to know that like you can discuss your doubts as well with me. Okay, so I think everybody is clear. Bias variance model. So you can say there's a balance between bias and variances because models with too few parameters are inaccurate because of the large bias, right? Not enough flexibility. Model with too many parameters are inaccurate because of large variances, right? Variances is too high, so its error is too much and too much sensitivity to the sample, right? Not enough flexibility. So this is the problem. Okay, so I think everybody is getting. Okay, so this is the formula for that. Test error, training error. There is a bias variance trade-off because there's an error. Low bias, you can say, and high variances. That is called the overfitting. So because there is an error in training error, high bias and low variance. This is called underfitting. In this, like uh, variance is very much high. So I think this is the question underfitting. And yes, this is underfitting problem, and this is overfitting problem. Right? Because underfitting we have a high bias and low variance, and overfitting is a problem. Then we have a low variance high variance, right? Many training examples, right? And we can consider like this few training examples, right? So number of training examples, testing, right? Generalization, error, right? No classifier is invented better than any. You need to make assumption to generate three kinds of error: inherited, bias, and variance. Due to oversimplification, unavoidable. Due to the inability to perfectly estimate parameters from the limited data, that's the problem. Right? How to reduce the? This is the question that has been asked many times. How to reduce the variance? This is the question. Choose a simple classifier, regularize the parameter, get a more training data. Right. This is the things that you can remove the like overfitting and anti-hitting problem. You need to use the L1 and L2. You can hit the penalty, and then yes, job is done. Right. Verify four tasks like pay, classify, and boost the decision tree, neural network. This is the very simple logistic regression, bias network, random forest, and all this thing. They are all aware. Descriptive model and generative model represent both the data and the label data, right? Naive Bayes classifier, and in this logistic regression, that is like regression that we don't have like to classify. Assume a simple boundary like a linear boosted decision tree, right? So model of the data may apply to the future prediction problem. Often easier to predict a label from the data than to model the data, right? Often predict a label from the data than to model the data. Models of data may apply to the future prediction problem, right? This is the problem, right? I hope everybody is getting clear. Assigns a vector to any two or more client decision rule divided into the space into the decision result separated by decision boundary, right? Assign the label nearest training data points to test data, right? Okay, so k nearest neighbor you can consider like this. Simple, a good one to try first within infinite. So I think till here we can stop. Five nearest neighbor, right? Three nearest neighbor, one nearest neighbor, right? K nearest neighbor, fine. But what if the data set is just too hard? Okay. So basically, data set data linearly separable workout get is the data set is what is too hard. What can be mapped to the hard dimensional space? So we can stop till here because it's too mathematical. So I think I will stop till here. Okay? Thank you very much.